Trigonometry. Now, in triangles, we've studied Pythagoras' rule, which states that in a right angle triangle, that this side squared plus this side squared will give you this side, which is hypotenuse squared. Okay, now if you have a triangle, this side is 3, 4, it's easy to calculate this side, which is hypotenuse, as 5. Or you have any two sides, you can easily find the third side, provided it is a right angle triangle. Now, what if we have a triangle, we know just one side, x, and we have an angle here, y degrees, and that is all we have. How are we now going to calculate the other side? Now, you may think, how possible is this? Now, let's say we have a u standing at this point, okay, and you look at your friend standing on a tall building. This is a tall building with windows and doors. So this is your normal eyesight. You should see the door, but this time around you are looking at your friend, which is here. Okay, now you know the distance from you to the house. Let's say this distance where you're standing to the house is x cm. Now you also know the distance, the height, from here to this side. Let's call this height y. Using Pythagoras theorem, here is x cm. It's easy to now calculate this line here. Now we have instruments. Some instruments you can use to measure angles. Now as you're standing looking up, you can use such instruments to measure the angle formed when you look up. So this angle formed here as you're looking up, and some of such instruments are, we have one called a theodolite, we have another called a clinometer, and we have the most common, which you have in your math sets, which is called a protractor. Now, some of these instruments are used by engineers. Let's say as they are building structures, you want to measure an angle. Now for them, it's easy for them to calculate the angle and already know the distance, but they don't want to know the heights. Okay, so for such, you now have a triangle, you know this angle x, and you have this height. How do you now calculate these other heights on this side? And now brings us to a principle called SOHCAHTOA. SOHCAHTOA, this is very important, and means sine, standing for S, equals opposites divided by the hypotenuse. Okay, so sine of the angle equals opposite over hypotenuse, and cosine equals adjacent divided by hypotenuse. Then another one called tangent, tan, equals opposites over adjacent. So let me write it this way, that sine equals that is OH, equals opposite over the hypotenuse. Then K, which is C, is our cosine, is same thing as adjacent divided by the hypotenuse. I want to have it that the tangent equals opposites all over the adjacent. Okay, now anytime you open your calculator, you always see this. Let me change this to a scientific calculator. You always see it here. Look at it, sine, cos, and tan. So sine means the opposite divided by hypotenuse, the cosine means adjacent over hypotenuse, and the tangent now equals opposites over the adjacent. Okay, now let's explore this further. So it means that when we have a triangle, here is 4 and this side is 3, we're told to find this angle, let's call it alpha. So since we have the opposite of the angle, which is this 4, and we have the adjacent, we have opposites and we have the adjacent, which of these will fit very well to find the angle is this, since we already have opposite and adjacent. So that means that tan of the angle, tan alpha, equals opposites over adjacent. That means tan alpha equals opposite, which is 4 all over 3. So we have it that tan alpha equals 4 over 3. Now at this level, we'll stop at tan alpha. When we get to higher classes, SS1 or 2, you'll be taught how to find the angle, which is alpha. Okay? Now, can we find, since we now know tan alpha to be 4 over 3, can we find cos alpha and also sine alpha? Yeah, it is possible. Using Pythagoras theorem, we have this as 4, 3, and that means here is 5. So that means sine alpha will be opposite over hypotenuse. Our opposite is 4 and our hypotenuse is 5. Then cos alpha is adjacent over hypotenuse. Our adjacent is 3 and our hypotenuse is 5. So we have tan alpha, cos alpha, and sine alpha. Okay, now let's look at some other examples. Okay, so our first example goes this way. If cos alpha equals 4 over 5, find sine alpha and tan alpha. So let's draw a triangle and let's call this angle alpha. Although that cos alpha equals 4 over 5, and cos is adjacent over hypotenuse, that means this equals adjacent over hypotenuse. And where is our adjacent? Our adjacent is here and our hypotenuse is here, 5. Using Pythagoras theorem, we have it that this side equals 3. That means our sine alpha will now be opposite over hypotenuse, which is 3 over 5, and our tan alpha will now be equal to opposite over adjacent, which is opposite over adjacent, which now gives us 3 all over 4. Okay. Now let's take another example. And this example says a ladder 6 meters long is leaning against a vertical wall. The end makes angle 45 degrees with the horizontal ground. How high up the wall does the ladder reach? Okay, so we'll have it that a ladder 6 meters long is leaning against a vertical wall. So the ladder is here and it's 6 meters long, is leaning against a vertical wall. The end makes angle 45 degrees with the horizontal ground. So this is the ground, makes angle 45 degrees with the horizontal ground. How high up the wall does the ladder reach? So we're told to calculate this angle x. So that means we have this angle and this x is the opposite, and we have the hypotenuse. So when we have opposite of our hypotenuse, from SOHCAHTOA, which one fits is the sine. So we'll have it as sine 45 equals opposite of our hypotenuse, which is x all over 6. So x will now be equal to 6 times sine 45. Now at this point, I want you to open your 4-figure table and search for sine 45, while I'll use my calculator to find sine 45. So I'll type 45 sine, and that gives me 0.707. Then I'll multiply it by 6, and our final answer is 4.24. So x equals 4.24 meters, and this is our final answer. Okay, now let's look at another concept called the angle of elevation and angle of depression. Now let's say this is your eye. Your normal sight, when you're looking, you look this way. Now anytime you look at a figure, alright. Now anytime you look at a figure high up, that means your eye has to go up. Now the angle formed when you look up, let's call it theta, is called the angle of elevation, because you are looking up. And anytime you look down, the angle formed, let's call it alpha, from the horizontal normal eyesight, is called the angle of depression. Okay, so with this, when you apply this look at our Pythagoras theorem, it's easy now to calculate either this distance or this distance or this distance for our angle of elevation or angle of depression. Now let's take one example of angle of elevation or depression, and it goes this way. The angle of elevation of the top of a tree from an observer standing 12 meters away from the foot of the tree is 45 degrees. Calculate the height of the tree. So we're told that this is a tree this way, and the angle of elevation of the top of the tree, let's say this is the observer, angle of elevation of the top of the tree from an observer standing 12 meters away from the foot of the tree is 40 degrees. Calculate the height of the tree. Okay, so how do you find the height of the tree? So to find the height of the tree, you have the angle 40 degrees, and we have 12 meters. Sorry, let me draw this very well. This is the person's eye. And this is a tree. And the person looks up, forming 40 degrees. And here is 12 meters. So this gives us a triangle with the base as 12 meters. And this angle as 40 degrees. And we're told to calculate x. So we'll have the adjacent and the opposite. So anytime we have adjacent and opposites, tan fits in. So we'll have it at tan 40 equals opposite over adjacent, which is x over 12. Therefore x will be 12 times tan 40. So check from our 4-figure table. Tan 40 times 12. So let's write 40 and we'll press our tan. It gives us 0.839, then times 12, and gives us 10.069. So our answer is 10.069. 10.069. If you approximate it, you have 10.1 meters, and that is the height of the tree. So now at this point, I want to click on Start Quiz and answer all the questions following.